Okay, next one, d by dx of 25 to the power log tan x to the base 5. You can cancel only if the base of the number and base of the log are same. But here base of the log is 5, base of the number is 25. So what should I
square.
do?
Written as 5
It will be tan
square.
square.
Yeah, you must write it as correct. 5 square, you must write it as then log tan x to the base 5.
Then the power can be shifted.
That will become d by dx of 5 square because they got multiplied tan x to the base 5. That became d by dx of 5 to the power log tan square x.
To the base 5.
Now cancellation property is applicable.
Okay.
So now this became d by dx of, they both got cancelled. This and log 5 will get cancelled. Then d by dx of tan square x. Now you have to apply power rule. So what will be the answer?
2 tan x into derivative of tan x. That is sec square x.
Very good, excellent. So 2 tan x into sec square x. That's your final answer. I hope you have written this example too.
1 second, sir. I'm still writing.
Please write both examples. For type number 2. Type number 2 is, this also we have done yesterday, log of a to the base a function. The functions of this type. So write example. D by dx of log of 10 to the base, let's say cortex. What to do in this case? You will write this as log a divided by log f of x. Then you will be able to differentiate. So this will become d by dx of
Log 10 divided by log cortex.
Yeah, log 10 divided by log cortex. Now log 10 goes outside. Derivative of 1 upon log cortex. Now how to differentiate that?
So log
Remember, one important thing. When I write this way, the base of the log is e. The base of the log is e. So it is log 10 to the base e. Okay. Now tell me how to differentiate this. How to differentiate 1 upon
So
log.
can we inverse log cortex?
How will you write it as?
log
Log
cortex
cortex
raised to minus 1.
Minus 1.
Log x raised to minus 1. Excellent.
Minus 1.
Very good.
Then we apply power rule for that.
Yeah. So log 10 to the base e minus 1 into log cot x raised to minus 2 into d by dx of
Log cortex.
Now your answer became log 10 to the base e. Minus 1 will remain numerator. Log cot x the whole square will remain as it is in the denominator. Derivative of log cot x will be 1 upon cot x
Into derivative of cortex.
So that became minus log 10 upon log cot x the whole square. And this became 1 upon cot x into derivative of cot x become minus cosec square x. So this minus and this minus will become plus. So finally it will become log 10 upon log cot x the whole square into cosec square x upon cot x. Minus will go away. Be careful, they may convert this into sine and cos and make it into sine 2x. So that you have to do it if it is MCQ in that manner is given. Now we come to type number 3. That is a function of this form. Log of function to the base a. So it will be written as log of the function divided by the log of the constant. Remember again, the base is c. When it is base c, then only derivative of log x is 1 by x. I hope you know this. This formula is applicable only when the base of the log is c. If the base is anything else than e, you can't write the answer as 1 by x. Okay, write this. You please do yourself this example. D by dx of log of cos x to the base 10. Start writing with me. It's a simple one, so I don't think it should be a problem. So what should I write after this?
D by dx of log cos x to the divided by log 10.
Yeah, divided by log 10. Now the log 10's base is c. Log cos x base is also e. Even if you don't write, it's fine. So 1 by log 10 to the base e into d by dx of log cos x. Now give me your answer.
It will be minus sin x upon log 10 into cos x.
Let's go systematically. 1 upon cos x into derivative of cos x.
Cos x.
Arundhati, this is fine?
Yes, sir.
Yeah. Yes, answer is minus tan x. Okay. Now why did I do this problem is, in fact, I had done this problem before, but I want to just tell you one more thing. This 1 by log 10 to the base c can be written as log e to the base 10 minus and cot x. So one of the option in the MCQ, suppose given to you, log e to the base 10, it is correct because 1 by log a to the base b is log b to the base a. All right, base and this can be interchanged by taking the reciprocal of the number. This tan x, not cot x. Type number 4. So we are going to do now derivative of the functions of this form. Log of a function to the base a function. Here also method is same thing. Log of the numerator, log of the f of x divided by log of g of x. Okay, you can write an example for this. D by dx of log sin x to the base x square. Log of sin x to the base x square. So how will you write this as?
D by dx of log sin x divided by log x square.
Yeah.
And they both have the base e.
Both are base c. So if you even if you don't write the base, it's fine. It's understood that the base is c. So whenever the base c, we don't have to write the base. Now I'm going to write one more step for my convenience. Instead of log x square, I'm writing as 2 log x.
2 log x.
So the derivative will become a little more easier for me. Now tell me, how will I find the derivative of this? Which rule should I apply?
U by V.
Very good. Derivative of u divided by v. V into derivative of u minus u into derivative of v upon v square. This is called presence of mind. You should remember that this is a quotient rule to be applied here. So my answer now will become, start from the denominator, d by dx of numerator minus numerator into d by dx of denominator.
Divided by denominator square.
Yeah, divided by denominator square. I could have also taken this 1 by 2 outside and done the derivative. That would have been better, in fact. So it became 2 log sin x, 2 log x. Derivative of log sin x, 1 by sin x into
Derivative
derivative
of
of sin x. You can directly write cos x. In a big problem, directly you can write the answer. Minus log sin x into 2 by x divided by 4 log x the whole square. So now 2 becomes common. So log x into cos x upon sin x minus 1 by x into log sin x divided by 4 log x the whole square. This 2 and this 2 can be cancelled. If you would have taken this 2 beginning only, then this cancellation was not required. So to make the answer a little more look better, you may take this x as LCM, x log x into cot x minus log sin x divided by 2x log x the whole square. So type number 5. Log of many terms with power. Let's say u1 raised to n1, u2 raised to n2 divided by v1 raised to m1, v2 raised to m2. That means what? u1, u2, v1, v2, all these are functions of x, but powers are all numbers. How will I find the derivative of this? For example, d by dx of log of, let's say, sine square x, then x square plus 1 raised to 4 divided by root of 2x plus 3 into log x. Suppose I want to find the derivative of this. Then we don't apply directly 1 by u derivative of u.
First, you need to differentiate the entire term.
No, that will take too much time. So what we do in this case is, when there are many terms with multiplication power, etc., we apply log's property. What is log m into n?
Log n plus log n.
log n.
Log m plus log n. What is log m by n?
Log n
Log m minus
log
log n.
Log m minus log n. And what is log a to the power n? N log.
N log a.
n log a.
So if you combine all these property, 3 property together, if you have log a square into b cube upon p square into q raised to 4, we can write this as
2 log a plus 3 log b
plus 3 log b.
minus 2 log p minus 4 log q.
Yes, very good. Minus 4 log q. This I explained to you last class. Am I right or wrong?
Yes, sir.
Yeah.
So I can write this as
2
d
log,
by dx of
2 log sin x
2 log sin x
plus 4 log x square plus 1
plus 4 log x square plus 1
minus
Then
half
minus
of
half
2x plus
log
3 log of
2x
2x
plus
plus
3
minus
3
is
half. Why minus came? Because in denominator.
because it's denominator
Half came because root.
and
And
minus
last
log
one,
x.
minus
log.
log of log x. Have you all followed this?
yes, sir.
Yes, sir.
Now we can differentiate all of them directly. 2 into derivative of log sin x because addition and subtraction directly we can apply. No product rule to be applied. Directly you can apply the derivative. So my answer will be 2 into 1 upon sin x into derivative of sin x plus 4 into 1 upon x square plus 1 into derivative of x square plus 1 minus 1 by 2 into 1 upon 2x plus 3 into derivative of 2x plus 3 minus 1 upon log x into derivative of log x. So this became 2 times cos upon sine, so cot x. 4 into 2x upon x square plus 1. So I can write 8x. Minus half into 2 upon 2x plus 3. So this 2 will get cancelled. Minus 1 upon log x into derivative of log x. I hope you understood this.
Yes, sir.
Yes, sir.
Now type number 5, no? Type number 5. No, type number 6. 6. Now this is a very important one. Look at this. Imagine a function in this manner. Base also has got x in it. Power also has got x in it. How will I find the derivative? Look at this type of questions which I'm writing. Don't write this. And suppose I write sine raised to 5x. Derivative of 5 raised to sine x. And derivative of x to the power sine x. What have you noticed the difference between all the three? What are the difference? How you do this one? Power rule.
Yes.
How do you do this one? Exponential rule. Repeat the function. Log of the base into derivative of the power. Barabar hai na?
Yes, sir.
But for this one, no formula. We don't have a method to differentiate. We don't have a formula to differentiate this. So in this type, I'm teaching you how to differentiate such type of problem. But you understand the difference between these three? Power is a constant, base is a constant, both have direct formula. But if both base and power are functions of x, then we do not have a formula. So let's try to differentiate that. Suppose I want to differentiate x to the power sine x. So I will call y equal to x to the power sine x. Everybody agree with this? Then take log on both the sides. So I have not differentiated. What did I do? What I did?
Log on both the sides.
Take log on both the sides. When you take log on both the side and then apply the property of the log. What is the property of log you can apply here? This sin x can be brought in front. Now tell me whether you can differentiate this left and right hand side.
Yes, sir.
How do you differentiate right hand side? What is the method of differentiating right hand side?
You can use product rule here.
You will apply the product rule. But you are going to differentiate with respect to which variable? You are going to differentiate with respect to x because you want to find dy by dx. You want to find the derivative of the function. Function is y. So your aim is to find dy by dx. So differentiating with respect to x, what will be this one? D by dx of log y. Y is not a constant. Y is a function of x. Now tell me the derivative of log y. respect to x? Tell me the answer.
D by dy of log y into dy
Log,
by dy.
what was the derivative log sin x?
Log sin x is 1 by sin x into log of
Derivative
derivative of cos x. Sin x, sorry.
derivative sin x. So ये sin x के जगह पे y आ गया तो क्या होगा?
It should be
1 by
1 by y
into
into
derivative of y.
and here you'll apply product rule. Sin x into derivative of log x plus log x into derivative of sin x.
square of
So remember that I want only dy by dx, but I have 1 by y dy by dx on the left hand side. And here let me complete differentiation. Is it fine? Now, since I want dy by dx, what I'll do? I'll cross multiply this y. Is it fine? Now replace y back here because you want the answer all to be in x. So x to the power sin x. Y is nothing but x to the power sin x into sin x upon x plus log x into cos x. This becomes your final answer. I followed? Is it clear? So y x raised to x, base and powers are functions of x. So you have to take log, apply the property of log, then differentiate. So 1 by y dy by dx. And you have to apply product rule here. X into derivative of log x plus log x into derivative of x. So 1 by y dy by dx is x into 1 by x plus log x into 1. This x and this x will get cancelled. So dy by dx will be y times 1 plus log x. And y will be replaced by x to the power x. Now this is a formula to be remembered. Remember this as a formula. What is the formula? This is for JE and MSCG. D by dx of x to the power x is x to the power x into 1 plus log x. Is it fine?
Yes, sir.
Yes, Joker. Noran correct. Nandana correct. Atharva. No, Atharva is not given. All right, let's learn another one. So what have you noticed here is multiplication. So should I change the method or should I do some other method? You tell me. How do I come to know that I should change the method or not to change the method? You have to think in your mind. If I put log here, can I expand it? If I put a log in front of this, can I expand it? If I can expand it,
Yes,
I
sir.
should directly take log. Yes, we can expand. So you start directly. Log y is equal to log of x to the power tan x into tan x to the power x. Now apply the logs property. Log of x to the power tan x plus log of tan x to the power x. Did you understand how the plus has come?
Log m into log n wala rule. You
Yeah,
applied
log m into n can be written as log
that. Log m plus log n.
Now what is next? One more property you can apply. What is that? Tan x is brought in front into log x.
Yes. X.
X into log tan x.
X log tan x.
That is log y. Now it is possible for you to differentiate. So after applying all the properties of log, it is possible to differentiate. So now differentiate with respect to x. So d by dx of log y is equal to d by dx of tan x into log x plus d by dx of x into log tan x. So what will be the derivative log by Austin?
Yes, sir. 1 by
Derivative
y,
log by,
1 by y into dy by dx.
yeah. And what about the right hand side?
It's a
What
product rule.
product rule? Very good. So dy by dx is y will cross multiply tan x into 1 by x log x into sec square x plus x into sec square x upon tan x plus log tan x. So your final answer will be dy by dx is x to the power tan x into tan x to the power x into tan x upon x plus log x into sec square x. Plus x into sec square x upon tan x plus log tan x. This is your final answer. Suppose the middle side was a plus sign here. Then what would happen? If I would apply log on both the side, this would become wrong. Because log of m plus n, we do not have any formula. Even log of m minus n, we do not have formula. So if the middle sign is plus or minus sign, we cannot apply log directly. Have you understood?
Yes.
So write a question. If y is equal to x to the power sin x plus sin x to the power x, find dy by dx. So can anybody tell me what to do for this case? Can anybody give me an idea? Nobody has any idea to do this.
Sir, we can take individual log.
Individual log. Very good. Excellent. What we'll do? We'll find out the derivative of this separately and add them up. So what I'm going to do is let u is equal to x to the power sin x and v is equal to sin x to the power x. Then derivative of y will be derivative of u plus v. Because this is u, this is v. So naturally this become derivative of u plus derivative of v. And each one of them I'll find separately. So I'll find the derivative of u separately, derivative of v separately, and substitute. So let's start. So start writing. First we'll call one function as u, another function as v, then find the derivative of each one separately. Because u has got both x as base and power, you have to take the log. So take log on both sides. Log of x to the power sin x. Apply log's property, sin x into log x. Now differentiate this with respect to x. So d by dx of log u is sin x into d by dx of log x plus log x into d by dx of sin x. So that became 1 by u du by dx is sin x into 1 by x plus log x into cos x. So what is du by dx? U times sin x upon x plus log x into cos x. So u can be replaced back. X to the power sin x into sin x upon x plus log x into cos x. This is equation number 2. Then you will take v sin x raised to x. Take log, please complete it yourself. So log v is equal to log of sin x to the power x. So 1 by v dv by dx. Before that, you have to make log's property of. So log v is x times log sin x. So 1 by v dv by dx. V times x into 1 by sin x into derivative sin x. And this becomes log sin x into 1. So v can be replaced now.
Sin x raised to x.
into
X times cot
cot.
x. Sorry.
Yeah, that's log sin. This is equation number 3. Now you'll write the final answer. Substituting 1, 2, and 3 in 1. Substitute 2 and 3 in 1. So dy by dx will be, instead of du by dx, what will write? X to the power sin x to sin x upon x plus log x into cos x. And instead of dv by dx, sin x raised to x into x cot x plus log sin x. This is a most common question in the board exam. You ask me which question came so many times. This is the one which is coming every time for 4 marks.
So we can take direct log.
Okay, I am taking log, direct log I am taking. Log x to the power x to the power x. So whatever the power that can come in front.
Yes, sir. By log x log x base x.
Log x. Now tell me, how should I differentiate this? Again, I don't know how to differentiate this. X to the power x has to be differentiated separately, or once more you have to take log. So there are two methods. Method number one, you will differentiate directly. So you will get d by dx of log y is equal to d by dx of x to the power x into log x. Then you will differentiate this y into dy by dx is x raised to x into derivative of log x plus log x into derivative of x raised to x. Now this you will calculate separately. So I'll write one more step and then I'll separate it. X raised to x into 1 by x plus log x into derivative of x raised to x. This one's answer I'll replace later. So dy by dx will be y times x to the power x divided by x plus log x into derivative of x to the power x. Call it as equation number 1. Then I'll take x to the power x separately. Then I'll take log for that. Then I'll differentiate this. So 1 by u into derivative of u is x into 1 by x plus log x into 1. So du by dx is u into 1 plus log x. That means x to the power x into 1 plus log x. This is a lengthy method. Now I'll replace this here. So now I can write my final answer. So substituting 2 in 1. So dy by dx will be, in place of y, I can write x to the power x to the power x. X raised to x upon x plus log x. And x raised to x derivative I've already calculated here, x raised to x into 1 plus log x. So now x raised to x became common. So my answer is 1 by x plus log x into 1 plus log x. This is one method of doing the problem.
So you found the derivative of u separately, but earlier in the earlier sum, you gave a formula, so that we can directly substitute it, right?
Yeah, if it is x raised to x, you can directly try. Suppose it is tan x raised to tan x raised to tan x, then you can't do that. Understood?
Yes, sir.
Yeah, it's better for you to, that x raised to x formula is applicable only for any competitive exam. Otherwise, in the board exam, you got to do it fully. Now I'll teach you method 2. Are you ready or still writing?
Done.
Done? Everybody, Austin completed? Atharva completed?
Yes, sir. Done.
No, sir, 1 minute.
Yeah, then why don't you speak up?
Yes, sir, I was just writing last day.
Now, method 2 is take log once again here. Instead of doing separately, one more time you take the log. So you can reduce your step. What you'll do? Take log again. So log of log y is log of x to the power x into log x. So log of log y can be separated like this. Log of the first term, so that is x log x, plus log of log x. I'll write it 2 steps. 1 minute. Log of x to the power x plus log of log x. Is this clear? Log m into n, log m plus log m. So log of log y is x log x plus log of log x. Now you will differentiate. Till now we have not differentiated it. Now we are going to differentiate it. So let me use some other color. So d by dx of log y is equal to d by dx of x log x plus d by dx of log x. So what will be the derivative? 1 by log y into derivative of log y. This will apply product rule. X into 1 by x plus log x into 1 plus 1 by log x into 1 by x. I don't want to length, I'm just directly differentiated. So 1 by log y into 1 by y dy by dx is 1 plus log x plus 1 by x log x. So you want a dy by dx to be the subject. So y times log y into 1 plus log x plus 1 upon x log x. Now wherever y is there, substitute. What does y stands for? X raised to x. Raised to x. Where does log y stands for? Here, log y. Log y is x to the power x into log x. Now what is the bracket? 1 plus log x plus 1 upon x log x. If you open this bracket, you will notice that this answer and this answer are same. But you can leave your answer like this one. Have you followed?